Yeah, very good evening, students. I'm just giving you a brief idea what about the process in finding the solutions of Mathematics 1 paper that is held today, that is on 4th June 2022 in the morning session, and common to civil, mechanical, EC and other branches here. Only for the morning paper, I'm just giving you the outlines how you are going to find out your solution, and you can verify your answers also. So it's a Corona paper, so I just give you the brief outline of each and every individual question. First A bit, asking to find out the rank of the matrix. A matrix is given, here it is 4 by 4 matrix, by reducing into normal form. Normal form in the sense you can use both row and column operations, and directly it should be converted into purely identity matrix. You try to find out that particular process and you can directly find out the final answer. 1b bit, prove that matrix is unitary. In order to say a matrix is unitary, a into a power theta equal to I. That is the process in order to get the unitary matrix. So already a is given. Try to find out a power theta, and from that you take the multiplication of a and a power theta. Definitely you are going to get I matrix. Once it is unitary, then you need to calculate inverse. So inverse is nothing but, for this inverse, whenever I am writing a into a power theta equal to I, it is looking like a into b equal to I. Automatically you can say that b is the inverse of a. So whatever may be the a power theta is there, that itself is nothing but inverse of given matrix. That is the clue that you need to remember. Second A bit, apply Gauss elimination method in order to solve the equations. So we have the equations here, it is. You are using the procedure given in the Gauss elimination method and try to find out the solution. After getting the solution, better use your calculator. Directly you can find out its solution and just you make the comparison that values of x, y, z must satisfied by all the given equations. Second B bit, apply Gauss-Jordan method in order to solve the equations. For your kind information, as per the syllabus, Gauss-Jordan method is applicable only to find out the inverse of the given matrix. But here they have given solve the equations. Actually this is not applicable as per the syllabus. So maybe this is out of your syllabus. Definitely those who are attempting your second B bit, you will get the marks. But solving is nothing but, instead of using Gauss-Jordan method, either you can use Gauss-Seidel method in order to find out the solution. But already 2a is solving of the equations, 2b is also solving of the equation. That I am getting some confusion here. Definitely Gauss-Jordan method is applicable only to find out the inverse of the matrix as per your syllabus, R18 syllabus. Third A bit, find the eigenvalues and eigenvectors of the matrix. A matrix is given, directly you calculate eigenvalues and eigenvectors corresponding to the matrix. Third B bit, you are verifying Cayley-Hamilton theorem for the matrix. So already 2 by 2 matrix is there, directly you can find out, verify your Cayley-Hamilton theorem, and along with you can also calculate the inverse. After getting that expression they have given, that expression you are representing as a linear polynomial. So that matrix you directly substitute it, you will get one type of expression. That expression is nothing but, it is the linear polynomial in A. So you are going to get only in terms of A matrix. Just you can use your Cayley-Hamilton theorem on whatever may be the characteristic equation. There you are getting almost, it is compare with your given expression. You are getting one and the same. From that you are going to get one expression. That expression is nothing but a linear polynomial. Fourth one, reduce the quadratic form. A quadratic form is given. You are converting into canonical form by orthogonal reduction. So this is the lengthiest process in order to get your final answer. For that, here it is given 15 marks. Better you can use it. Fifth A bit, discuss the convergence of a particular series is given. For that particular series of positive terms, try to write down the general term. A general term, just you look at this, it is looking like n power n x power n divided by n factorial. So that is nothing but a general term. From that you can use better you can apply any one of the methods, but the best route is nothing but Cauchy root test. It's a general procedure. Whenever you are getting general term power is n, you can apply Cauchy root test in order to verify the convergence. Fifth B-bit. Test whether the series is absolutely convergent or not. This is an alternating series. First you verify with the help of your alternating series whether it is convergent or not. After verifying that, directly you can take the absolute series. Once again you verify it. If it is convergent, you call it as absolute convergent. If it is not, you can say that conditional convergence. Sixth A-bit. State Rolle's theorem. You are just writing the Rolle's theorem statement. Verify a function is given in the interval 1, 3. So it has to satisfy three properties. Once three properties are satisfied, directly you can find out the C value which is lying in the open interval 1, 3. Sixth B-bit. You are finding the area of the tangent cut off the team parabola equation is given and line equation is given. So you can calculate the surface area corresponding to the two equations. So we have a separate formula to find out the surface area corresponding to the two equations. Just you find out that surface area. And in seventh A-bit, express one integral in terms of gamma function. Here that can be started with 1 minus x power n equal to some t. From that only x power n equal to 1 minus t. Only x equal to 1 minus t whole power 1 by n. That value you can substitute in the integral, and the limits are also going to be changed. From that you are going to get one type of gamma function. After getting that gamma function, you can evaluate the next integral. Remember, always the integral gamma function limits 0 to infinity only. Since the limits are given 0 to 1, it should be converted into beta function. So directly you can use it in terms of beta function. Seventh B-bit. U is given a function and prove that that value equal to this. So U equal to function is given directly. In order to get your value, dou by dou x plus dou by dou y plus dou by dou z whole square can be taken as dou by dou x plus dou by dou y plus dou by dou z into dou u by dou x plus dou u by dou y plus dou u by dou z. Just you make that particular simplification and directly you will get the answer. Eighth A-bit. If u equal to cosec inverse of one expression is given and asking to find out that value by using Euler's theorem. Euler's theorem is applicable only for homogeneous function. So from that, u equal to cosec inverse of that expression means only that expression is nothing but cosec u. That cosec u I am supposing it as f. So f equal to that expression here it is given. First you verify that f is homogeneous or not. If it is homogeneous, then directly you can use your Euler's theorem. Almost it is homogeneous. You can also find out its degree, and from that x into dou f by dou x plus y into dou f by dou y, that is equal to n into f value. From that you will get your required answer. Eighth B-bit. Find maximum and minima. A particular function is given having two variables. So you can directly calculate maximum value and minimum value depending on the values you are getting for D and L. This is the brief outline corresponding to M1 paper of the morning session of JNTUH Hyderabad morning session paper, question paper, M1 paper. So just you verify my outlines whether you attempted in the examination center. If it is almost the same, definitely you will get a maximum score. So have a good day.